Hello students, today in this class we are going to start with the chapter 4 of class 5, that is solids, liquids and gases. So in this class we are going to study what are solids, what are liquids and what are gases. So these are nothing but the various states of matter. So before going to this, we should know what is matter and what is this matter made up of. Yes? So in detail we are going to study what is matter, what are types of matter, what are states of matter, so what is this matter is made up of. All these things we are going to study in this chapter. Okay? Yes. All things whether living or non-living are made up of matter. Yes. So whether it is in a living thing, whether it is in a non-living thing, yes, these are made up of a matter. Anything that has mass and occupies space is called matter. So what is matter? Anything that has mass and occupies space is called matter. For example, take table. Table, if you lift, you can feel the weight, correct? And if you keep at a place, it will occupy some space. It requires space, correct? So anything which has a mass and occupies space is called as matter. Example, they have given here table, chair, water, milk, air, glass, spoon, jug, correct? Anything for a matter, correct? A matter is made up of a very small particles called molecules. So for this, I can give an example. Take a chalk, correct? Take a chalk and make it powder. So before it was a matter, and when you make a powder, you can see a small particles. The small particles can considered as a molecule. So chalk as a matter is made up of a tiny small particles called as molecule. So each molecule combined to form one object. Correct? So on the basis of arrangement of molecules, matter exists in three states. So depending on the arrangement of molecules, matter has been divided into three states. What are the three states? Solid state, liquid state and gaseous state. So these are the three states of matter. First one is arrangement of molecules in solids. So how the arrangements of solids, how the arrangement of molecules will be there in solids. We'll see. In solids, molecules are very closely packed. As you can observe in the figure here, so the molecules are very tightly packed, correct? So it is compressed, tightly packed. So there is a strong force between the molecules. There is a strong force of attraction between the molecules. So when compared to first molecule and the second molecule, there is a huge attraction, correct? Strong force of attraction is there. So in solids, there will be a force of attraction is more and they cannot move away from each other because there is no space in between them. They can't move here and there. So solids are generally hard, rigid and have a definite shape and volume and cannot flow. Because of there is no gap in between them, they cannot flow, they cannot move. They are rigid and hard and they have a definite shape and also they cannot flow. These are some of the properties of solids. What are the properties? Solids are hard, solids are rigid, solids have definite shape, solids have definite volume and solids cannot flow. These are some of the properties of solids. Okay. Next we have arrangement of molecules in liquids. In liquids, the molecules are not very close to each other due to weak force of attraction between them. So compare the diagram of solids and liquids. See in solids how the arrangement, there was no gap in between the molecule and molecule, but here you can see some gap, correct? You can see some gap. So in liquids, the molecules are not very close to each other due to weak force of attraction. Here the force of attraction is weak. So the molecules in liquids can move and slide over each other because of there is a gap in between the molecules. They can move freely. This makes liquid flow. Liquids take the shape of the container. So when in the solids, the shape is fixed. Here, liquids take the shape of container. If you pour it in glass, it will take the shape of glass. If you put it in bucket, it will take the shape of bucket. If you put it in pot, it will take the shape of pot. Okay, so solid, I mean liquids take the shape of the container. So liquids do not have a definite shape, but they have definite volume. So what is the meaning of the sentence? They do not have definite shape, but they have definite volume. It means, so if you take 1 liter of water, if you put it in bottle, it will be 1 liter. If you put it in bucket, it will be 1 liter. If you put it in jug, also it will be 1 liter. The liter will not change, the volume won't change, but the shape will change. Okay, that is the meaning of this sentence. Understood? Next, arrangement of molecules in gases. How the arrangement of molecules will be there in gases? In gases, the force of attraction between the molecules is very weak. In liquids, it is weak. In gases, it is very weak. See, you can observe here in the diagram. So when compared to this and this, it is very weak. The molecules are more far. Correct. So there is a more gap also. So the force of attraction between the molecules is very weak. So the molecules in gases are far apart from each other. The molecules are far apart from each other. And they are free to move. When compared to liquids, the gases can move more faster. This makes the gas flow easily and fill the container completely in which they are kept. Okay. See here, liquid. If you pour the liquid, it will occupy only the required amount. But in gases, if you put the gas, it will fill the complete container. If you put it in jug, it will fill complete jug. If you put it in bucket, it will fill complete bucket. Correct? Why? Because the molecules are free to move. The molecules are free to move so that they can absorb, they can conquer all the space. See, any substances that can flow is fluid. Thus, all liquids and gases are fluids. What they're telling? The substances that can flow, they are called as fluids. Since they are called as fluids, gases can flow, liquids can flow. So both gas and liquids are called as fluids. Next, change in state. So what do you mean by change in state? Change in state is nothing but changing of liquid to solid, solid to gas, solid to liquid, liquid to gas. These are nothing but examples of change in state. In previous classes, you have learned that matter can change from one form to another on heating or cooling. Correct? In the previous classes, you have studied, right? So like ice cubes can convert into water, water can be converted into ice cube. Correct? The same water can be converted into water vapors. So these are some of the examples of change in state. Do you know how this happens? Let's see the effect of heating or cooling on the molecules of matter. So what happens if we heat the object and what happens if we cool the object? First one is evaporation. The change of liquid into its gaseous state on heating is called evaporation. What is evaporation? Changing of liquid to gas. For example, water into vapors. Water into water vapor is called as evaporation. The changing of liquid into its gaseous state on heating is called as evaporation. So when water is heated, it changes into water vapor. This is because on heating, the water molecules start moving faster. So in water, there will be molecules, right? So these molecules, when they get heat energy, they will start moving very faster. So they become free and escape into the air in the form of water vapor. So as they are moving faster, they become free and get escape into air in the form of water vapor and can move much more freely. Okay. So first there will be the force of attraction will be weak. The molecules movement also slow. So when you start heating it, it will gain heat energy and start moving faster, and the force of attraction become very weak, and also they start moving into air. Next, condensation. What do you mean by condensation? When steam get cooled, it condenses to form water again. So as I told you in the previous example, the water is going to convert into water vapor. So when this water vapor captured and condense means cool. The water vapor ನಾವು ಯಾವಾಗ cool ಮಾಡ್ತೀರಾ, so when this water vapor get cooled, it becomes water again. So this happens because on cooling steam, the movement of water molecules becomes slower, they start to move close to each other, they become less free to move and thus come closer to each other to form water. So when you start heating, it becomes more faster. The movement of molecules become more faster and they convert it into air. The same water vapor, when you cool it, when you condense, so the fast moving molecules will become slower and they get closer. Closer means heat ಮಾಡಿದಾಗ ತುಂಬಾ ದೂರ ಹೋಗಿತ್ತು, so cool ಮಾಡಿದಾಗ it will come down, so it will come closer. So they become less free to move and thus come closer to each other to form water. The change of gaseous state into liquid state on cooling is called condensation. Okay, so the change of gaseous state into liquid state on cooling is called as condensation. Then what do you mean by melting? So ice is a solid. When it is kept at a warm place, the movement of molecules in ice increases and they become free from the rigid form. They become loosely packed and form water. So when you take the ice cube from the refrigerator and keep it out for some time, you cannot see the ice cubes, where you can see only water. So what about the ice cubes? So the ice cubes have been absorbed the heat from the atmosphere and they got converted into water. Okay, simply they will not convert, they absorb the heat present in the atmosphere and due to this heat energy, the molecules start moving faster and then they converted into water. So the change of solid state into liquid state on heating is called as melting. Changing of solid state, that is ice cube, into liquid state, that is water, on heating. Here no one is going to heat, it is absorbing the heat present in the atmosphere. Okay, so this process is called as melting. And the last concept is freezing. So what do you mean by freezing? Freezing in the sense, when you cool water, the movement of its molecules slow down, they come very close to each other and pack into a rigid shape. So you take the water, and you have the water, the molecules are close to each other, not very close, they are close to each other. When you again cool it, the molecules still come closer and form a rigid surface. So that rigid object is called as ice cube. So they come very close to each other and pack into a rigid shape to form ice. So the change of liquid to solid on cooling is called as freezing. So here they have given complete explanation in a expression. See, ice, when you melt, it becomes water. Water, when you evaporate, it will become steam. Again, steam, when you condense, it become water. Water, again, if you freeze, it will become ice. So this is a example of reversible change. It is an example of reversible change, and also it is an example of physical change. Okay, so this about changes you are going to study in this next chapter. Okay, next you have solids in water. Take a glass of water, add a few crystals of sugar in it and stir. You find that particles of sugar disappear. Where have the sugar particles gone? The molecules of sugar take up the space between the molecules of water, so we can say that sugar gets dissolved in water. So what do you mean by solids in water? So what happens when solids get dissolved or when mixed with water? So as you all know, the molecules in water have some space. There is a space between the molecules in liquids, correct? So since water is a liquid, there is a gap between the molecules. So when you add solid content to the water, for example, they have taken sugar here. Sugar is a solid particles. When you add sugar to water and stir it, so where does this sugar disappear? What happens to the sugar? You cannot see the sugar after some time, correct? So where does this sugar gone? So these sugar particles have been dissolved in water. These sugar particles have been dissolved in water. So these sugar particles or these sugar molecules got occupied in the space between the space between the molecules of water. Correct. So there was a gap between the molecules in liquid. So that gap has been filled with these sugar particles. Okay. So this is one of the example of solids in water. Similarly, what happens in liquids in water? So you must have seen that the painter removed paint from its hand by using turpentine oil, not water. This is because paints get dissolved in turpentine oil. Some liquids to remove, see some paints. If you're the painter after painting, if you want to wash the hands, he used turpentine oil. So what do you mean turpentine oil? Turpentine oil is also again it is a liquid. So this liquid can mix with the paint, or the paint can be dissolved in turpentine oil. Okay, so turpentine oil can easily be removed, whereas it does not dissolve in water. So if you wash it with water, the paint, if you wash it with water, it won't wash out because this paint will not mix with water. So it is dissolved in turpentine oil. So if you wash the hands with your turpentine oil, the paints get removed. So the water cannot be used to remove turpentine oil. Okay. Some of the liquids when mixed together dissolved in each other. For example, liquids like glycerin and alcohol dissolve in water. However, some liquids that mix together do not dissolve in each other. For example, kerosene oil and vegetable oil do not dissolve in water. So this concept is nothing but you have two types of liquids: miscible liquids, immiscible liquids. So miscible liquids in the sense the two liquids, or the liquid which is going to mix with water, completely mixed with water, they are called as miscible liquids. For example, lemon juice. Lemon juice, when you add to water, it will get completely mixed. When you add vinegar to water, it will get completely mixed. When you add cool drinks to water, it will get completely mixed. So these are some of the liquids are called as miscible. Why? Because they are completely mixed with water. And some liquids, they are not mixed with water, they are called as immiscible liquids. For example, kerosene oil, groundnut oil, vegetable oil. So these oil will not completely mix with water. If you mix with water also, they form the layers. Below there will be a water layer, above there will be an oil layer. They will not mix. So such type of liquids are called as immiscible liquids. Next, gases in water. How these gases react with water. So when you boil water, you observe some bubbles are formed along with the side of the beaker. Yes. So here also you can observe when they're going to boil the water, you can see the bubbles coming from the down. So what is this bubble? These bubbles are the gas which is mixed with the water. So in the earlier classes we have been studied, right? The aquatic animals absorb the dissolved oxygen present in the water. Right? So the dissolved oxygen is a gas which is present inside the water. Okay. These are the dissolved gases that get separated from the water on heating. The gases like carbon dioxide and oxygen dissolved in water. For example, water in rivers, oceans, and lakes has oxygen dissolved in it. Yes. So this dissolved oxygen is utilized by the aquatic animals. You must have seen that when you open a bottle of aerated drinks, then bubbles of gas comes out. These are bubbles of carbon dioxide gas which have been dissolved in water under great pressure. So when you are going to open the cool drink like Coca-Cola, Pepsi, Sprite, so when you're going to open this, so as your cap opens, there you can see the gas coming out of it, bubbles coming out of it. So this is the carbon dioxide gas which is compressed with the water. Okay, so that is about the gases in water. So next we are going to study expansion of matter. So what do you mean by expansion of matter? Expansion means expand. When you spread the rubber band, it will get expanded. Similarly, the matter also can expand. We'll see what matter can expand. When we heat a substance, its size increases. The increase in size of the matter is called as expansion of matter. What do you mean by expansion of matter? The increase in size of matter. If the size of the matter increases, then we can tell that it has been expanded. On heating a substance, the movement of particle increases and the space between them also increases. As I told you, when you heat an object, it increases, it absorbs the heat energy and increases in its size. And also the space between the molecules also increases. So the substance get expanded. For example, to open a tight metal lid of jar, we dip it in a hot water because the heat of water causes the lid to expand a little and it opens out easily. If you have closed the lid and it has been fixed tight, so if you want to remove the tight lid, you can put that container in a hot water, so that hot water will expand the lid so that it will be easy to open the jar. Next, contraction of matter. Contraction means it is an opposite of expansion. When we cool a substance, its size decreases. This decrease in size of matter is called as contraction of matter. For both expansion and contraction, I can give you an example. So I think most of the people have been see the bullock carts in Kinagadi, correct? So these bullock carts, they were using previously back, they were using 2 tires, correct? So these tires are made up of wooden, correct? So these wooden tires are circulated, or the circular part of the tire have been fixed with the outer iron ring. So how to insert this iron ring to the wooden wheel? First, they are going to heat. They are going to heat the iron ring till it becomes red hot. Then they are going to place this wooden tire inside that ring and they are going to pour the water on the hot red iron ring. See, here you can observe when they boil or when they heat this iron ring, it becomes red hot. So that when you heat the iron, it will get expanded. It will be expanded. Okay. Just a second, I can show you here. So this is your wooden wheel, correct? And this is your iron ring. One more thing you need to understand carefully: iron ring and wooden wheel will be of same size. Then only they can fix easily. Okay. So when you heat this iron ring, it will become red hot. So that it will be expanded. It will increase its size. So when this iron ring expanded, so they will insert this wooden wheel inside this ring. And what they will do, they will pour the water on the iron ring. So when they pour the water on the iron ring, it get contract. That's what they're going to tell you. See here. See, when we cool a substance, its size decreases. When they pour the water on the wheel, it will decrease its size. So this decrease in size of matter is called as contraction of matter. On cooling, the movement of particles of matter slows down, they becomes close to each other. The space between them decreases, so the matter contracts. That is why electric cables do not appear loose in winter while they hang loosely from poles in summer. The electric cable wires in the poles, they are made up of iron. So during the summer, they get heated and they are hanging loosely. Where in winter, because it is cool, the matter gets cools down and become rigid. Okay, they decrease in size. Okay, this is the concept they have been explained in this para. Okay, next we have physical and chemical change. This is the last concept, physical and chemical changes. What do you mean by physical change and what do you mean by chemical change? When a change occurs only in shape, size and state of matter is called physical change. If the change is going to take place only in shape, size and state of matter, then that type of change is called as physical change. And it is also a temporary change and can be reversed. And in physical change, there is no new substance is formed during the change. Okay, main points: change occurs only in shape, size, and state of matter. This is a temporary change. This can be a reversible change, and no new substance is formed in this change. Okay. For example, I can tell you melting of ice into ice in conversion of ice into water, water into vapor, vapor into water, water into ice cubes. Correct? Here, what is going to change? State of matter is going to change, and size is going to change, shape is going to change. So this type of change can be said as physical change. A physical change may occur due to heating or cooling. For example, when you heat a water, it changes into steam. On cooling steam, it changes into water again. Similarly, when you freeze water, it changes into ice. On keeping the ice in the warm place, it changes into water again. Other examples of physical change are stretching of rubber band and cutting of hair. So that example I have told you, the conversion of ice cubes into water, water into gas, gas into water, water into ice cubes. Similarly, other examples are stretching of rubber band. So if you stretch a rubber band and leave it, it will come back to its same position. Similarly, cutting of hair. If you cut the hair, after some days, it will regrow, correct? It will grow again. So these are some of the examples of physical change. Chemical change. When the matter changes altogether to form a new substance, it is called as chemical change. See there, no new substance is formed. In chemical change, there is a formation of new substance. And it is a temporary change. The physical change is a temporary change, but chemical change is a permanent change. Physical change is reversible, but here chemical change is irreversible, cannot be reversed. Okay. For example, when you burn a piece of paper, it changes into ash. This is a chemical change because when we burn paper, it changes it completely into new substance. It becomes ash and we cannot get paper back. So when you burn a paper, the paper can convert it into ash. Ash is a new substance. It is here when the change considered, the change produces a new substance, then it will be a chemical change. Here, the burning of paper is a chemical change. Why? Because it has been changed into a new product called as ash. And from ash, you cannot be changed into paper. So that is irreversible change. Okay. Yes. So other examples of chemical changes are making a chapati from wheat flour, curdling of milk, making of rice, etc. So from wheat flour you can make chapati. From chapati you cannot make wheat flour. Similarly, from milk you can make curd. From curd you cannot make milk. So these are some of the examples of chemical change and irreversible change. So this completes the chapter solids, liquids and gases. So hope everyone understood. Thank you, students.